Welcome or welcome back at C Square. In this lesson we will talk about angle of elevation, angle of depression, and also we're going to use this angle of elevation and depression for solving real life application. First of all, let's take a look, and we have this first picture here where a person, an observer, is looking up to this bird. Okay, this angle you see here formed by this line of sight, and this horizontal line is called angle of elevation. So basically if you look up you have something that we call angle of elevation. On the other hand, in this picture you notice the observer is on the top of the building and is looking down. This is the line of sight, and this is an horizontal line. This is the angle of depression, how we call it. Like I said, with these two angles and trigonometric ratio, we can solve real-life application involving indirect measurement. Like this one, you are flying your drone at the park and the angle of elevation is 27.2 degrees. This is the angle. Your drone is 72 feet above the ground and you are 6 feet tall, so that is very important. We have two things here. This is 72, and yes, you are 6 feet tall. How far is your drone? Okay, so you already notice we have this triangle here. We can draw it. However, you need to be careful, because first of all, in this triangle you need to find this side, this leg, because this is a right triangle, right? And that side is going to be nothing else than 72 minus 6. Let me call this h. That will be 72 minus 6, which is 66 feet. Okay, and now we have that triangle, like I said, and this is 27.2 degrees, this is 66, and we need to find how far the drone is. So the drone is right here, the person is right here. I will say we need to find this x. This is the distance from the person to the drone. That is how far it is. So what trigonometric ratio we're gonna use here? If you notice, we have the angle, we have the opposite leg, and we have the hypotenuse. Opposite leg, hypotenuse, and the angle. That means we have to use sine of 27.2 equals 66. That is the first thing you're gonna put on the numerator, and over x. So you need to solve for x. I will solve it by multiplying by x first to get rid of this x, which means x cannot be 0, by the way, which is not, obviously. So we end up with this equation, and we have to do one more step to solve for x. Divide by sine of 27.2 to get rid of this sine of 27.2. Don't forget to do on the other side the same thing. And what you see here is the exact solution, the exact value. X equals 66 over sine of 27.2. However, we need to do an estimation round to the nearest foot, so we need a calculator, which I'm gonna grab it, and be careful how you put it. 66 divided by sine of 27.2, and I end up with 144.3, so it's gonna be rounded to the nearest foot. That will be 144 feet. The distance between you and your drone is 144 feet. Very similar, this problem. The only difference, we have the angle of depression, and you need to be very careful here. We can draw two triangles, but I think this one is the best. And let me use this black marker here, right? But let's read the problem maybe. The angle of depression. The angle of depression, if you remember, is this one. Is 10 degrees, this one. And we need to find how far the boat is. If the height of the lighthouse is 120 feet, that means this height here is 120 feet. Now, very fast, we know this angle is also 10 degrees. Why? Because this angle and this angle are alternate interior angles, so they are congruent. So now we can do the triangle here. 120, this is 10, and we need to find how far is the boat from the lighthouse. So again, we need to find, I will say now is the distance is this. It's because it says from the lighthouse, the base of the lighthouse. So now we have what here? We have the angle. This is the opposite leg, and this is the adjacent leg, opposite leg, adjacent leg. That goes with tangent. So we have tangent of 10 degrees equals 120 over x. Very similar to the previous problem. I'm going to multiply by x to get rid of this x. So we have x tangent of 10 equals 120. Divide by tangent of 10. And we have this exact value. And now we're gonna put this in the calculator and see what we get. And I end up with 680.5. I'm gonna round it to the nearest foot, so I will say x equals 681 feet. That is how far away is this boat from the base of the lighthouse. Okay. Sometimes you'll need to draw a picture. Yeah, sometimes a picture is not given to you, like in this problem. We have this gentleman here who measured the angle of elevation of a weather balloon as 34 degrees. So the gentleman is right here. He measured this angle as being 34 degrees. A radio signal from the balloon indicates that it's 1,400 meters from his location. So this one is 1,400 meters. To the nearest meter, how high above the ground is the balloon? So this is the thing they ask us. This x, the height, or h, if you want to call it like that, it doesn't matter. So again, we notice we have a right triangle. We have the angle of elevation. Then we're looking, we want to find the opposite leg, and we have the hypotenuse. So we're going to use sine. So we're going to have sine of 34 equals opposite x over hypotenuse 1400. In this case, we're going to multiply by 1400. And we have x equals 1400 times sine of 34. This is the exact value, however, we need to find it to the nearest 10. So again, the calculator, within the calculator, and I end up with 782. I need to the nearest meter, so 783 meters. Okay, that is how high above the ground is the balloon. You notice that the height of the person who's doing this measurement is not important in this problem. Sometimes it is. Another example, very similar, when you have a tourist look out from the crown of Statue of Liberty, approximately 250 feet above the ground. So the tourist is here, 250 feet above the ground. The tourist sees a ship coming into the harbor and measure of angle of depression as 18 degrees. So now you need to be careful. Okay, this is the angle that is 18 degrees. But you notice I drew another triangle, and that means this angle here is 18 degrees because these two angles are alternate interior angle. Find the distance from the base of the statue to the ship to the nearest foot. So find this x. So we're looking here, we have the angle, we have the opposite leg, we have the adjacent leg that we need to find out. Opposite, adjacent with the angle, that means tangent again. So we have tangent of 18 degrees equals 250 opposite first over adjacent then. Very similar, multiply by x. We did that in a couple of problems. By now you know. X tangent of 18 equals to 50, and the last step, divide by tangent of 18. I was going to cancel this tangent of 18. Don't forget to do on the other side, obviously. And this is the exact answer. X equals to 50 over tangent of 18. Now we don't need this. We need to do an approximation to the nearest foot, but obviously we need this for finding the answer they're looking for. So we're going to do 250 divided by tangent of 18 degrees, and I end up with 769 nearest foot. That is the approximation, 769 feet. That is how far away from the base of the statue is the ship. My last part of the lesson will be about this situation where you notice you have two angles, in this case of depression. From the top of a building, of a 100-feet building, a man observes cars moving. If the angle of depression changes from 29 to 17, we can see that also in the picture during the period of the observation, how far the car travels. So I will say here, first of all, try to see the triangle you're going to use, the triangles. In fact, the triangles are this one. You notice here we have this small one we're going to use. Also we have a big one here. So there are two triangles here. I'm going to separate them when I will do this problem. Now what you want to notice, this angle here, it's also 17 because it's congruent to these alternate interior angles, and this angle here will be also 29 degrees because it's alternate interior angle with this angle. So let's say the big triangle. Where this angle is 17 degrees. Now the height of the building, it tells us in the problem, is 100 feet. And we need to find this piece in this triangle, which is going to give us the distance from the base of the building to this position where the car is at the end of the problem. So we're going to have to do what trigonometric ratio? We have the angle. This is the opposite, and again we're looking for the adjacent, so we're gonna use the tangent of 17 equals opposite 100 over adjacent. Let me call it x, this piece. So very similar, we did problem like this, we're gonna end up with x equals 100 over tangent of 17. Of course, multiply by x and then divide by tangent of 17 if you want. So that is this piece from this point to this point, like I said. Oh, we have another triangle, that small triangle. Let me change the color to emphasize. This is the triangle. Now I'm gonna use the small triangle, like I said. And very similar the math. Just the numbers are different, just a number, right? This is the triangle, the small one. The same 100, just this angle is now 29. And we're gonna need to find this piece, so I'm gonna call it y now. Obviously it's the same trigonometric ratio because I have the angle, the opposite leg is 100, and I'm looking for the adjacent. So I'm gonna have tangent of 29 equals 100 over y. Very similar, y will be nothing else than 100 over tangent of 29. So what else we need to do to find the distance between the how far the car travel? Look at here, this is this piece, this is the piece we're looking for, and you notice already is the red segment, this x. So let me call this d. So this d is the red segment, this x, minus the blue segment, which was y. So the exact value will be 100 over tangent of 17 minus 100 over tangent of 29. This is the exact value. Now let's do an approximation in the calculator. So we have 100 divide by tangent of 17 minus 100 divide by tangent of 29. I end up with 146.6. I'm gonna round it to the nearest foot, so I'm gonna say 147 feet if you round to the nearest foot. The last problem in today's lesson is, like I said very similar with the previous one. The only difference, we're gonna have angle of elevation. You are flying your drone at the park, and the angle of elevation changed from 30 degrees to 15 degrees. The drone is 52 feet above the ground, and you are 5.5 feet tall. So important also that piece. How far does your drone fly? First of all, similar with the other problem, I'm gonna draw this triangle. You see the triangles that help me to solve this problem. You notice there are two triangles. There are the big one and the small one. This angle here will be the same with this one. They are alternate interior angles, 15 degrees, and this one for the small triangle will be 30 degrees like this one. Okay, so now before we do anything else, we want to find how big this piece is, or this two triangle, and for that reason I'm going to look again back to the problem, which says the drone is 52 feet above the ground, and the height you have is 5.5. So what else we need to do first? We do this subtraction to get this segment. We have to do 52 minus 5.5. And I end up with 46.5. So that is this leg of this two triangle, 46.5. Now I can start, I'm going to start similar with the big triangle. You can start with the small triangle, obviously. And again, this is 46.5. This angle is 30. And we need to find, the big triangle, the angle is 15. Since I said the big, this is 15. And we need to find this x. Again, we have the angle, we have the opposite leg when we're looking for the adjacent. So by now you know is tangent. Tangent of 15 degrees equals 46.5 over x. So x will be 46.5 over tangent of 15. But very similar, we're going to have to take the small triangle now. Where this angle now is 30 degrees. And this is still 46.5. Let me be sure I put the dot there, 46.5. Again, we need to find this leg now, which I call it y. And again, we have the angle, we have the opposite leg. Angle, opposite, we're looking for the adjacent, so we have tangent. Tangent of 30 degrees equals 46.5 over y. Very similar, we get the y. Y will be 46.5 over tangent of 30. And what do you think we need to do here? I mean, we did something very similar in the previous problem. We need to find this segment. This will show us how far the drone fly. I'm going to call this D. Okay, if you notice this, that D, very similar with the previous problem, is nothing else than x minus y. So we're going to have 46.5 over tangent of 15 degrees minus 46.5 over tangent of 30. I'm going to put this in the calculator and we'll see what we get. 46.5 divided by tangent of 15 degrees minus 46.5 divided by tangent of 30 degrees. And up with 93, exactly 93 feet. So that is the distance the drone is flying when the angle of elevation change from 30 degree to 15 degree. If you enjoyed this lesson, don't forget to click the like button. Come back and see Square for more lessons or more help. Thank you.